Hi, I'm here today to present GnuPharma's science overview. We'll start with GnuPharma's mission statement, and our mission statement is to serve really by providing health and wellness solutions based on our science and technologies. We're committed to providing natural solutions to health and wellness issues. Well, let's start our presentation here today on GnuPharma science with really an explanation of where current science is in their explanations really of the human body and how the human body functions. So let's start with an explanation of hemostasis. I think any medical professional will recognize that hemostasis is something that the body's constantly striving for, but hemostasis is the goal. But if you ask really any knowledgeable medical professional how our body attains hemostasis, I think you'll get a myriad of answers that vary quite dramatically. So, how do our bodies regulate? Well, again, as I just mentioned, it depends on who you ask, but certainly there's not a clear explanation of the regulatory system of our bodies. If you ask a hormonal guy, he's going to say through hormones. If you ask a nervous system guy, he's going to say through the CNS. And there are certainly other explanations of how the body regulates. But we do know this about how regulation works, that certainly the hypothalamus is involved, and that, again, just kind of depends on the system what kind of explanation you get. All right, so let's look at a very specific system. And again, here, the explanations get a little fuzzy as we sort of elevate out from the organ level, I guess, or the cellular level, if you will. But if you ask a researcher, scientist, explain to me our digestive system and explain to me really feeding craving or why we get hungry, you're going to get an explanation of really our digestive system, which is what this slide describes. And then further, you're going to get an explanation of ghrelin and dopamine and leptin and how these hormones, kind of play a role in hungry full. But they don't really explain why we get hungry, and they don't really explain why we feel full. All right, so with that kind of background, let's go ahead and delve into a little bit about what we've done here at GnuPharma. So let's talk about the background of our discovery. So first of all, let's bring you up to speed on something called the endocannabinoid system. So many of you may or may not know what the endocannabinoid system is. But it's an internal system that was discovered in the 90s. It incidentally was discovered by the same guy who discovered THC in cannabis, a guy named Raphael Mashum. And in the early 90s, he discovered an internal ligand for the same system that cannabis affects internally called anandamide. And he also discovered basically the CB1 neuroreceptor. And so he coined this discovery in this new internal system, the endocannabinoid system. Well, this system has been heavily studied by pharma, and again, if you go to nih.gov, I think you can prove that to yourself very quickly. There's thousands and thousands and thousands of papers on this system, and this system certainly appears to be responsible for regulation of many internal systems, and we'll talk more about that in a second. But, what has pharma done with this? Well, pharma has developed a few drugs around this system, and in particular, they went after the CB1 neuroreceptor and did something called antagonize it or block it, and they did so with a drug called rimonabant. They did this because they felt like this would be a therapeutic vector basically for weight loss. The drug rimonabant works spectacularly well for weight loss, so it turns out that blocking the CB1 neuroreceptor is a great way to cause people to lose weight. However, it also caused many people in the study, and again, this went to human trials and clinical studies. It caused many people on the trial to suffer from extreme depression, and they even had a couple of suicides in the trial. So they immediately, obviously, stopped the trial. And very valuable information learned here. So CB1, good clinical target for weight loss, but CB1 also, as a result, regrettably, of their negative outcome, but good clinical target for mood. So very interesting results, but it also, this particular go scared pharma pretty bad about the system. So why haven't we seen more products from pharma? Well, they really it's hard to patent things in this system because it's so closely related to cannabis, and cannabis is so controversial. They wrongly really assume that cannabis is the major influencer of this system. And they really don't have their research fully gunned up on the endocannabinoid system because of cannabis fears. And it's really been, in the last, 10 years, I would say that it's become readily known that plant-based flavonoids can influence this same system. All right, so let's take us to a gentleman by the name of Chip Paul, which is me. I'm an entrepreneur, researcher, and inventor, but back in 2014, my wife and I became very interested in medical cannabis. We founded an organization in Oklahoma called Oklahomans for Health. We were actually the proponent of something called SQ 788, which ended up finally becoming a state question in Oklahoma in 2016. But we really fought for this in 2014, and long story short, I had to be the front man basically for this organization. And so I had to speak for the organization and speak in front of media and doctors and, medical professionals, all of that. So before I did that, I was going to make sure that I had my ducks in a row and I really understood what was going on here. But what I quickly learned was that cannabis really isn't the magic here. The magic is its ability to influence this internal system, which is truly the magic. So, I started researching at this time, and that's kind of the background of that. But what did I really discover? Well, what I discovered, first of all, was there's a ton of research on this system. But I discovered enough to really begin to see that if you go down any human system, so let's say immune system or reproductive system or feeding craving system, it really doesn't matter how you slice and dice a human being, but depending on how you're looking at a human, there's many research papers that heavily indicate that the endocannabinoid system would be the everything regulation system in that subsystem. So, for instance, lots and lots of deep and heavy research on the immune system and how the endocannabinoid system really sits above and controls that immune system and immune system response. Okay, so let's look in a little bit more detail as to what our model, or GnuPharma's model of the ECS looks like. We all understand how a car works or a vehicle works, or even if you take a sophisticated piece of machinery like an airplane or something like that. But our cars work with a computer, and the computer in our vehicles through a sensor array is able to really touch a bunch of monitoring points throughout our vehicle, and through basically mechanisms of action, able to make changes to enhance the efficiency overall of our vehicle. So the computer in our vehicle may be making changes to our oil pressure, or temperature of engine fluids, or all different kinds of things to optimize the efficiency of our vehicle. So we fully understand the idea of this computer being kind of the hemostasis manager of a vehicle, or the regulation manager of a vehicle. Well, how does that apply to what we're talking about? Well, very similarly, we believe that this endocannabinoid system is really your everything system. It certainly sits above the central nervous system, and again, there's research that indicates that very heavily. In fact, your neurons fire differently under an endocannabinoid event than they would under a normal, if you will, CNS event. The ligands are manufactured on demand, so they're synthesized, and they have to be synthesized from resources rather than stored in vesicles like a dopamine or serotonin event. But anyway, what happens here in our model is that your hypothalamus, and again, I really think down to almost like the spreadsheet, what's your vitamin A level, what's your vitamin B level, that type register, but keeps track of your resource levels. It keeps track of basically, any reparative actions that are going on, any issues with your body at all. But the way that it does this specifically is through the endocannabinoid system. And the endocannabinoid system contains enough chemical messengers and extends through sort of the sensor array of our body to be able to gain this feedback and also perform actions down to the cellular level. So from the cellular level up through organs, all the way up through CNS to the brain, the hypothalamus through the endocannabinoid system is able to be basically the mechanism of action for the body. All right, so let's get a little bit more specific. So again, it's helpful to visualize things, I think, with this new system. And an umbrella certainly is a good visualization or analogy. So, the ECS is kind of our umbrella system here, and it sits above the central nervous system. It exercises influence over the central nervous system in a variety of ways, but certainly by, minimally CB1, CB2 interaction. It exercises control over the pituitary axis, really through the hypothalamus and its control over that axis. And it exercises control over every single cell in your body. So every cell in your body will respond to an endocannabinoid stimulus, and that certainly is not the case when any other system in your body. And there's some supporting statements, down there that certainly feel free to satisfy yourself with the research. All right. So how does the ECS influence? How does this influence happen? Well, certainly the hypothalamus, and in some cases the hippocampus. Again, if it's autonomic, it's probably hippocampus, and if it's higher order, then it's hypothalamus. But how does it influence us? So if you think about organ control is generally done, first of all, by CNS action, but then through hormones. And hormones are used to up and down regulate organs. Anandamide is a key ligand in this system, as is 2-AG. Both of those are very important lipids, neurotransmitters in this system, and those are used to perform CNS actions. And then if you look at kind of how your central nervous system works, and again, if you look at the upper right-hand portion of the slide here to this neuron, you see the arrow there, direction, message, travels. Well, we were all taught in, whenever it was, 8th or 9th grade science, that certainly is the case, and that really electricity or, electromessaging can only travel one way down your neurology. Turns out that's not true. There's a back channel here and something called retrograde signaling that only can take place because of the endocannabinoid system. So it's that basic and kind of an integral part of your neurology. So what about this system? What drives it? What runs it? Well, let's just look at this simple neuron slide here. And you'll notice that there are neurotransmitters stored in what's pictured here as little yellow sacs, but these are called vesicles. And this is the way that a normal CNS event happens. So these little vesicles basically release neurotransmitters into the synaptic cleft, and then those neurotransmitters plug into neuroreceptors on the other side of the synapse, and this basically sends the message, performs the action. Now, in an ECS event, I don't have this drawing up because it's very complicated, but the neurotransmitters are not stored in vesicles. They are actually manufactured, and it's usually on the postsynaptic side of the response, and then they're retrograde signaled back to the presynaptic side. But your signaling and your ability to basically store resources, you do not store resources in the ECS system. Basically, you use what's available at the time of synthesis or on demand. So it's a heavily resource-backed system. You have to have these resources or you honestly don't fire right in your neurology. All right, so let's go through, in the slide at the beginning of the presentation, I talked a little bit about hungry, full, and kind of what current science explanation is of how are we hungry, how are we full. And let's walk through this now with some new eyes and kind of our new model. So again, we mentioned the hypothalamus in our model, and the hypothalamus really, we think, is the computer in your car, so to speak. So he's constantly monitoring, our body for hemostasis, but he's constantly monitoring us really down to the cellular level for need. When a need threshold is hit, he will release basically something called ghrelin, and ghrelin will cue basically you to be hungry. So that's what creates stomach, sort of cramps and hunger cramps. What we know of as hunger pains is ghrelin. But again, that starts with the hypothalamus. That release mechanism is through the endocannabinoid system. Ghrelin is released, you get hungry, nutrients are absorbed. Now this is very important because again, Current science really doesn't explain this, but as these nutrients are being absorbed, this is an on-demand system. So you're being monitored by your hypothalamus for nutrients. And as satiety levels become achieved, then the hypothalamus will cue you to be full. But these things are being monitored, I don't know how precisely, but certainly very, very precisely by your hypothalamus. And when it, reaches its satiety level, then again, through the endocannabinoid system, the hypothalamus releases a hormone called leptin, and then leptin is what kind of shuts down the whole scenario and says full. But the important thing to recognize here is there's a tremendous amount of feedback and management and control that goes on between the hypothalamus and the gut, the intestines, as absorption's happening, really the blood-brain barrier, all of those things being very closely and tightly monitored in something that's as simple as eating. So, is the ECS influenceable? It certainly is influenceable, and you can read about cannabis certainly is a way to influence, but there's plant-based flavonoids certainly influence the system, and if you want to satisfy yourself, there's a good resource right here. All right, so let's talk a little bit about how pharma finds things in nature, because I think that's an important, everybody always wants to make a distinction between herbal medications or, nutraceutical medications in pharma. So let's talk really about what pharma does and how they create a medicine, and let's talk about something called, the two brand names here are Theolair and acetate, but I always do these as something called theophylline. But basically these are, and they're on the far right hand side of the slide, but basically these are medications that a physician would prescribe for COPD or asthma patients. But as you look at how these medications are produced, let's talk about how pharma does this. So the first thing that they have to do, they go to nature really, and they're looking for an herb or a spice that has medicinal properties. So in this case, it's cocoa, and in some cases, tea also contains theobromine, but cocoa contains theobromine. So they go to nature and they find cocoa. And then they synthesize something called theobromine from the cocoa, and they have to have a single molecule because that's what they can patent, and then that's the way they can make money for the next 20 years in their protected environment. So that's what they do. They pull out theobromine, and then they take theobromine and they package it in some way that's not natural. So usually they'll put it in a capsule or in a starch-based pill or some kind of inhaler with a bunch of additives. But anyway, that is what is finally delivered to you. But this whole middle part about pulling it out of its natural element and then sticking it into an artificial one, to me is a little annoying, right? So how do we differ from pharma? Well, we don't do that. So we just take basically the raw herbs and we understand what the plant-based flavonoids are in that herb that we are after. And we use those plant-based flavonoids, in the ratios that we feel like are appropriate to build our formulations. All right, so let's talk a little bit just real quick about intervention therapies, because hopefully medical professionals are watching this presentation, and I want to talk about this because I think it's really important. And as you guys know, most intervention therapies are kind of in the middle of this slide, I guess. So hormones and steroids generally are the majority of probably drugs on the market. If we begin to look at like mood therapies and pain medications, those kind of move up into the CNS space. Certainly we have organ-specific therapies, but in general, again, those are hormones and steroids. And we have cellular-based therapies. What we're proposing is that there's a far better way to treat things. And if your body doesn't have the necessary resources to function, then we don't have any business moving down these umbrellas, right? So the first thing that we have to get right is let's get the body the natural resources that it needs to function properly. And then we can properly identify things that really aren't regulation issues. Because if you're regulating properly, your big umbrella is helping all your other little umbrellas kind of go. And if your other little umbrellas aren't working properly, then generally that means there's a genetic issue or a trauma. And in that case, we may treat those things in the sort of middle umbrellas here, certainly. And there's efficacy with our model actually influencing things down to the cellular level, which we certainly feel like we can do and do. But what we want to do is present that highest level umbrella with resources, and then let your body really decide, how it does things. All right, so why is this important? Really, all of kind of what I presented here today important. Well, first of all, we have a model, a scientific model that is certainly proving to be predictive and very reliably predictive. And it can really predict the behavior of basically a formulation, based if there's enough evidence based. So I'll give you an example of that. So let's take seizures, for example. So, if I'm looking at seizures, the first thing that I'm doing is I'm looking at current therapies for seizures, and I'm looking at what works. And so certainly there are calcium inhibition therapies that work for seizures, all right? So that to me would be a very important therapeutic target to go after seizures, or at least a beginning place. And we've actually done this, and we actually have a formulation that's working here with seizures. But basically, there are herbs, certainly, that block or will inhibit the calcium channel. And so those are good starting places. There's also herbs that you need to kind of do other things. But again, all this is known resource, right? So it's easy to kind of back engineer effective things for a therapeutic vector and then pursue that therapeutic vector under our kind of new eyes with our herbal system of influence. So we've been able to do that very effectively in what we feel like are several ways, and we certainly hope that we're, adding value, medically, which we think we are. So anyway, that is about all I have for today. Certainly feel free to contact us at info@GnuPharma.com or give us a call. Certainly feel free to peruse our website. And thank you very much. I appreciate your time today.